start section 3.6. We only got 2 more sections left in this chapter. Whew. We're going to focus on quadratics. So we've worked with quadratics a bunch. X squares, parabolas, our besties. We've had lots of them. So we're going to think about standard forms of equations. We're going to write equations for parabolas. We're going to write, like, this is going to be the most generic of generic forms for a parabola. And we're really focusing mostly on A, H, and K. B is not going to be super involved in these. So I'm going to put up the basic of transformation forms. That's our f of x. That's our a x minus h squared plus k. So this is that transformation form we've been working with when we were doing our graphing stuff, right? Familiar? This has another name when we're talking parabolas. Anyone remember what it is? Because this could be called our transformation form. Or it has another name. Remember what it is? A V. Vertex form. This is also our vertex form. Because the vertex of the parabola, that place like where our absolute values bounce, where our parabolas bounce, that change point, that important point, that center of our graph, that's our vertex. And our vertex happens at the point h, comma, k. Always, always, always. Our vertex is happening at h, comma, k. So when we're given problems that say like this, it says find a standard equation or find the standard equation of any parabola that has a vertex v. They're not telling us if there's a stretch or compress, so they're not telling us what that a is. We're going to leave a as an a because it could be any parabola that has this vertex. So what we're going to do is we're going to fill in the vertex. And that's going to kind of be it. So our vertex here at this point v, this is going to be my h, comma, k. So we're going to take those and substitute them in. So we're going to take that transformation form where we have our f of x. Why is my... No, I have an even number of wheels on places, but it's very wobbly today. F of x. I'm just writing the transformation form down again so we can look at it right next to each other. X minus h squared plus k. What are we going to substitute in for our x? Or I'm sorry, for our h? The -3. So we're going to have x minus -3, which becomes x plus 3 squared. And what's our k? 1. And what we're going to do is we're going to leave this a here. This is what makes it any. So our function, f of x, is this. Because any graph that has this kind of structure is going to have a vertex at -3, 1. If it has a stretch of 2, it would have a 2 in place of the a. If it had a compress by a factor of 4, we'd have 1/4 as my a. If it got reflected, it would still have this same vertex. So when they say give us the standard equation for any parabola that has this vertex, that's what we mean. We tend to overthink this one. Because we have a couple questions on the homework like this, and we overthink this one real hard. Okay? So we're going to do it again, just because we really overthink this one really hard. Okay? So, again, new vertex. 0, -2. So I'm going to put our kind of generic form up here again, just because I like to play match them up. F of x equals a x minus h squared plus k. So what's going in for our h? 0. What's going in for our k? -2. So we're adding -2. And we're keeping the letter a here. That's what makes it any. So let's simplify this a little bit because mine is a bit of a mess. My f of x, or my function, is going to be a, then what? Just x squared. X minus 0 is the same thing as x plus 0 is the same thing as x. And then -2. Ta-da! End of that question, okay? So we have a tendency to, like, overthink this one. Questions on these guys? It is indeed Thursday. Okay. So the next kind of question is we're going to be given a function and told to write it in vertex form. We're going to write it in vertex form or transformation form. Express f of x in the form a x minus h squared plus k. You have two options when approaching this. So option 1, hard mode but traditional, complete the square. Just like we did in circles. Bless you. Which we could absolutely do. We would take our x pieces, we would factor out my a, so we'd remove that -1. We'd have our x squared plus 4x plus blank to make our perfect square. Totally fine, absolutely valid. Option 2 is to find the vertex with the axis of symmetry. Boop. So if you are super confident and comfortable with completing the square, more power to you. Absolutely rock on. Track through. That is traditional way of doing this. Finding the vertex using our axis of symmetry is easier calculation-wise. Because our formula for the axis of symmetry, which we tend to put as AOS, because lots of words. Is very, very short. -b over 2a. And that tells us the x value of the vertex. So our axis of symmetry is -b over 2a, and that is an x value. So completing the square is 100% valid, but it is hard mode. That is not right. So let's do this one axis of symmetry style, just so we can see what I'm talking about. So my axis of symmetry, we're going to put our -b over 2a. What is our b?
4.
Our b is -4. So the opposite of -4 is +4. Over 2 times our a. 2 times, what's our a? -1. So 4 over 2 times -1 is going to be what? -2. That is the x value of our vertex, which in fact even is our h. So I'm just going to leave it as the equals x part, because that tells me in my vertex here, I've got a -2. How could I find the y value of my vertex? Substitute it in. So we're going to do f of -2. Substitute in the -2 into our function. The opposite of -2 squared minus 4 times -2 minus 5. -2 squared gives me 4. minus 4 times negative 2 gives me plus 8 minus 5. So we have negative 4 plus 8 minus 5. Negative 1. So my k is negative 1. This tells me my y value of my vertex, which is my k. So we want to write this in my vertex form. What is the a value? To write my equation, I need all the pieces, a, h, and k. Negative 1. The a value for vertex form is the same as the a value from standard form. So we're going to have our negative 1 times our x minus our h being our axis of symmetry, being our x value, being negative 2. So it's going to become x plus 2 quantity squared plus k minus 1. Okay, so you can 100% do this with completing the square. Totally fine, absolutely valid, works every time. This also works every time and is less calculatorily gross. Okay. Questions on this one? We're going to try it again, just, see it. Boop. Same vibe. We're going to write it in our transformation form or in our vertex form, and I'm giving you the standard form. So I'm going to start with finding my axis of symmetry. That's my negative b over 2a. So how are we going to build our axis of symmetry? 6. Opposite of negative 6 is positive 6 over, 2 times my a being negative 3. So 2 times negative 3, negative 6. So what is my axis of symmetry? Negative 1. That is the x value of my vertex. So if I'm trying to write my vertex as a point, I've got a negative 1 here, but I don't know my y yet. So to find my y, we're going to take our function and we're going to substitute in our negative 1. F of negative 1. Negative 3 times negative 1 squared minus 6 times negative 1 plus, minus 5. Oops. Helps when I write my equations down correctly. All right, so what's going to happen? What are we going to get? Either finish it or give me your answer. What do you get? Negative 2 as our y value. I'm like, where are y'all getting from negative 1 from? As our x value, negative 1, negative 2. There we go. So our y value is negative 2. This is a lot easier to simplify than completing the square sometimes. Absolutely valid. If you rock on completing the square, we felt really comfortable in that semicircle land, go for it. Absolutely works. So our transformed function, our f of x, how are we going to write our equation here? Negative 3, that's our a value. X plus 1 squared minus 2. Gorge. Okay? Just like that. Totally fine. We're going to do one more. And then we'll move on to something else. Questions on this one? Fraction-y grossness. But we can do this. So we have 2/5 x squared minus 12/5 x plus 23/5. We can't because it changes like our stretch and stuff, so we're just going to plow through with it being fractions anyway. Well, we'd have to multiply 5 to both sides, and that would change what our f of x is, so it would change our function. So we're just going to plow through with it being fractions, and we can do this, I promise. But doing it this way is going to be better than trying to complete the square with this. Just saying. So our axis of symmetry, what's going to be on the top? Yeah, 12/5 is on the top. So the opposite of negative 12/5 is positive 12/5. Ew. Our denominator is going to be 2 times 2/5, also known as 4/5. Now can we simplify this to make it less awful? Yeah. What is this going to simplify more to be? Okay, when in doubt, dividing a fraction by a fraction. Multiply by your reciprocal. 12/5 times 5/4. My 5's cancel. Or you can see that here is that since they're both fifths, you can cancel it here. So we wind up with 12/4, also known as 3. That's tolerable. We can do that. So in our vertex right now, I've got 3. Workable. That's doable. We can do that. So now we got to find the y value for our vertex. So we're going to do our f of 3. So we're going to have our 2/5 times 3 squared minus 12/5 times 3 plus 23/5. Whew, lots of fifths. So let's simplify each term individually, and then we can add them together. So we're going to have here our 3 squared. What's 3 squared? Times 2/5. So 18/5. Since we're multiplying our numerator. So we have 18/5 minus 12 times 3, 36/5, plus 23/5. So we have 18 minus 36 plus 23. Let me think it for a second. But yeah, you're right. When in doubt, switch them around. 18 plus 23, then minus 36. 5/5. Also known as 1. So this gross superfraction thing had a whole number vertex. Super ultra extra fraction still had whole numbers in its vertex. So writing this in our vertex form, we're going to have our, let me change colors, f of x equals, what do we get? 2/5 x minus 3 squared plus 1. Okay? So, bougie fancy. Not awful. We've had worse. This is not awful. Hopefully. Should hopefully be semi-familiar. We did this in Algebra 2. What? Chaos. what was that about, jumpy screen? Okay. Questions on this one? So we got a little bit more I want us to do today. Because I want us to remember how to find zeros of a function. And we're going to find our maximum or minimum value, meaning our vertex. And we're going to give it a little baby sketch. Not a graph proper, but a sketch. So, first thing we're going to do is try and find our zeros. They specifically tell us to use our quadratic formula. So, we got to remember what that is. What is quadratic formula? X equals opposite of b plus or minus square root b squared minus 4ac over 2a. That's an A. Looks like an O, but it's an A. That is an even worse A. There we go. You're going to have to know that. If you do not know that, go to YouTube and pick a song to learn it to. You got to know that one. There are a plethora of song options to help as mnemonics. The traditional one is Pop Goes the Weasel. I have seen it in so many, so good. Like, so bad that they're so good. Like, quadratic formula songs. Some of them are real winners. But, like, there's Dre, I think there's the Superman song, like, Superman. That one. Like, there's all kinds of them. I think Lean With It, Rock With It is one of them. Like, there's some interesting choices that were made for quadratic formula songs. There are some interesting choices. So, your favorite song has probably been turned into a quadratic formula song, and it will destroy it in the best way. So, if you don't know that off the top of your head, please learn it. You need to know it. So, let's find our roots. X equals, let's fill it in for this particular one. How are we going to fill it in? -4 plus or minus square root 16 minus 4ac. So what's it going to be? 36. Oop. Over 2. And I went a little aggressive on my fraction bar here. So let's simplify this. I've got my -4 plus or minus. What's inside my radical? -20. So what are our roots going to be? Imaginary. If I was to keep going and simplify, we'd have our -4 plus or minus 2i square root of 5. We're imaginary here. Which means, where does it cross the x-axis? It doesn't. Does it? We imagine that it does, but it doesn't actually cross it. That's what an imaginary root means, is there's no real roots. Good. Okay, we're also asked to find our vertex here. So just like we did on the last one, we're going to find our axis of symmetry and then use that to find the y value. So we also want to find our axis of symmetry. -b over 2a. That's an awfully familiar part of the quadratic formula. Oh my gosh, what? It's before the plus or minus stuff. Oh. -b over 2a is right there in the quadratic formula. All right, so what's our axis of symmetry going to be? Yeah, it's -4 over 2 times 1. So our axis of symmetry is -2. So our vertex is at the point -2, comma, let's find out. F of -2. When we find f of -2, what are we going to have? -2 squared gives us 4, plus 4 times -2, minus 8, plus 9. So 4 minus 8 plus 9. 5. So when we think about doing this as a little sketchy sketch, we know where our vertex is at 2, 5. We know we have imaginary roots, so it's never hitting the x-axis. We know our A is a +1, so is that going to point upwards or point downwards? Up. What's our y-intercept? That's an algebra 2, do we remember? What is the x value of a y-intercept? 0. So if x is 0, what's y? If x is 0, what's y? F of 0. 9. 0 squared plus 4 times 0 plus 9. So our y-intercept is whatever our c value is. So we know we have our vertex at -2, 5 point. We have a y-intercept at +9. We are vaguely happy face shaped. We point up because we have only imaginary roots. So sketchy sketch. Ta-da. We're going to do one more of these. Okay? And then that'll be it for today. One more of like this set of things. And then we'll be done and I'll give you guys the quiz. Okay? That'll give us a little bit of time even to look at it. Oh my gosh, what? Time? Who's she? We don't know her in here. Time. Whoop. Yep. Oh, you're right. We have to identify our maximum or minimum.
Is that the vertex?
Our maximum or minimum is always going to be the vertex. So do we have a maximum or do we have a minimum here?
Minimum.
We have a minimum. This is a low point. So this guy is also our minimum. A maximum would be a high point. So it would be if we had a vertical reflection. So if our vertex is a valley, it's a minimum. Because it's the lowest it can go. Okay, let's do one more like this. We're again going to use our quadratic formula to find our zeros, find our maximum or minimum, find our vertex. We're going to give a sketch. Same vibe, same dealio. So again, I'm going to write our quadratic formula up here just for those of us that aren't super confident on it yet. Negative b plus or minus the... What are we talking about?
He wants to factor out. Take out a 2.
I was going to say, the problem with factoring out a 2 is because if we divide both sides by 2, then we're changing f of x, which will change where things like y-intercepts are. It will change where the vertex is. It won't change our roots, so it wouldn't affect our quadratic formula part, but it will affect pretty much everything else. If it's factorable, you can always do that to find roots, but that doesn't help you with vertex. So factoring is not a bad instinct. It's just not going to work super great on this one. So looking for our roots. It's like I know a lot of you started flying through this one as soon as I put it up here. When we're working with our quadratic formula, what are we getting here? -16 plus or minus square root. Huh? Yeah, big numbers on this one, right? 256 minus 4 times 2 times negative 20, times negative 26. We get 208. Over 2 times a, so negative 4. So when we simplify this, what do we get under the radical? Or negative 4. Can we simplify square root of 48?
Absolutely.
Mm-hmm. Yeah, so this is negative 16 plus or minus 4 square root of 3. Because 16 times 3 gives us the 48. Over 4. So can we simplify this? Yeah. Remember how much we love to divide? Those guys get to divide. Or split it at your plus minus into 2 fractions. Negative 16 over 4. 4 square root of 3 over 4. So negative 16 divided by 4 gives us negative 4. Oh, on the bottom. Sorry. Boop. Ask. Straight up. I'm just like, Yep. So negative 16 divided by negative 4 gives us a positive 4. So we're going to have 4 square root of 3 divided by negative 4. Since we're doing plus or minus anyway, does it matter if we have it as a positive or a negative square root of 3? Mm-mm. If you're feeling really picky, you could put it as minus plus instead of plus or minus because it did switch the sign. But practically, it doesn't make any difference. So we have real roots. A little bit right of 4, a little bit left of 4. We have 2 real roots. Now let's find our vertex. So our axis of symmetry. What's our axis of symmetry going to be? Yeah, we have our negative 16 over our 2a, negative 4. So negative 16 divided by negative 4 gives us a positive 4. Again, our axis of symmetry pieces are in our quadratic formula. They're right there. So then we need to find our f of 4. To find our y value for our vertex, we're going to have our 4, comma, our negative 2 times 4 squared. I'm going to have our negative 32 plus 16 times 4, bring us 64, minus 26. Should be 6. So we have our roots being on slightly either side of 4. 4 plus square root of 3, 4 minus square root of 3. We've got our vertex at 4, 6. Where's our y-intercept? Negative 26 is our y-intercept. When x is 0, y is negative 26. How about, is this going to be a right side up smiley face or upside down frowny face? Upside down frowny face, because we have an a that is negative. So when we're doing our little sketch, we're almost there. Boop, boop. We've got our vertex at 4, 6, boop. Our roots are just barely off of 4. So square root of 3 is more than 1 but less than 2. Because 3 is between 1 and 4, are 2 perfect squares. So we have a maximum or a minimum on this one. Maximum. Take it to the max. Okay? So 3-6 deals a lot with parabolas. We're going to talk more about them tomorrow, okay? We're going to do some monkey things with it, but we're going to do some. So I'm going to pass you out the quiz. You guys turn it in tomorrow. Like this is, yes, tomorrow. It's Thursday. Today is Thursday. As a reminder, we're not the only person who's had that thought today. Today is Thursday. So you got to turn it in tomorrow. Do not be expecting to work on it on Saturday, because that's not tomorrow.
No, but like Monday, Tuesday, Wednesday.
What's that?
But then, it just not even.
No. A lot of people do turn it in tomorrow. No, yeah, you're telling yourself a lot. So I put up here our announcement page for 3-6.
Surprising, Miss Fish. Can you have a statement?
Stapler. Yes, up by the turn-in bin, there should be stapler.
We're not allowed to ask questions, right?
Is that on Monday?
I mean, you can. I might not answer it.
Wait, so for functions, you can't have the same x,
Correct.
but you can have the same y.
Correct. Each x goes to only one y. It's not that each y goes to only one x. That's 1-to-1. What's up?
On number 1, is that just a set of things?
Is that? Sorry, I missed the last word. Is that a set of?
What?
I missed the last word you said.
Oh, is it just a set of things?
Because each x doesn't equal 1 y.
Oh,
With the same y, they have different things.
I need this.
Okay, so this should hopefully be a good one for us. We need this to be a good one. Because the last one was kind of brutal.
Maybe the first one. This isn't.
I do not recall if I did it.